I am Prema Sundari from the Department of Civil Engineering, NPR College of Engineering and Technology. Today I share some topics from advanced surveying for third year civil engineering student. In second set shows the advanced surveying applications used in various field. The third slide shows the unit topics. Already we are discussed about some from this unit road surveys, curve, hydrographic surveying, measurement of current as discharge. Now I share some points from the tunnel alignment and setting out. First I introduce what is meant by tunnel. A tunnel is artificially constructed underground passage to bypass obstacles safely without disturbing the overburden. The open cut is an open to sky passage excavated through huge soil mass of obstacles in required directions to connect two road or two railways. Bridge is an overground construction to cross over obstacles without disturbing the natural way below it. The tunnels are underground passage for road or rail traffic, pedestrians, utilities, fresh water or sewer lines. This is the plan of the tunnel, and also this picture shows the open cut tunnel. This is also a picture shows the tunnel alignment. Then the tunnel ratio of the tunnel is to width is equal to 2:1. The tunnel must be completed enclosed on all sides along the length. The types of tunnels are classified based on three aspects. First one based on purpose. Next one based on surrounding material. Next based on size. First one based on purpose. It is having two types: road, rail, utilities. Next one based on surrounding materials: soft clay materials versus hard rock materials. Next, third method is submerged tunnels. In Egyptians and Babylonians constructed tunnels about 4,000 years ago with a length of 910 meter, width of tunnel 3,600 mm and height of the tunnel 4,500 mm. Then in Britain and France was constructed by the Channel Tunnel 1994. The total length of the tunnel was about 50 km, and it is under sea component itself is about 39 km. The primary objectives of the tunnel alignments are to reduce the transit times, then reduce the traffic, next increase quality and reliability of service, next minimize impact of surface transit operations in sensitive locations. Next point is economics of tunneling depends on first one nature of soil. The surrounding soil it having hard soil or soft soil. Next the surrounding rock materials. Next one the requirements of fill. Next depth of cut is greater than 18 meter. It is called tunneling. Next one, the tunneling is desirable when rapid transport facilities are required, which needs to avoid acquisition of land for roads. Tunnels are also erected when shortest road connection is needed in cities. Tunnels permit easy gradient and encourage high speed on strategic roads. Next one is tunnel design criteria. The tunnel it requires proper design. Every tunnel will have its own geometry design, alignment and construction method. The design criteria include the following. First one spatial requirement, alignment. Next one is underground station, fire life safety, tunnel alignment and operations. In every tunnel will require horizontal and vertical alignment. Next one tunnel ventilation, tunnel lighting, electrical safety equipment, drainage, fire life safety, security. Then next one is the following factors should be taken into consideration when selecting the method. First one tunnel dimension, next one tunnel geometry, next length of the tunnel, then total volume to be excavated, next geological and rock mechanic conditions to be tested, next groundwater level to be checked, next expected water inflow, next vibration resistance, next one is allowed ground settlements. Next one is selection of tunnel alignment depends on the first very important one, topography of area and points of entrance and exit. Next one is a selection of site of tunnel to be made considering 2 points. First one, alignment restraints. Next one, environmental consideration. Next one is classification of tunnel based on alignment. It having 4 types. First one, off-surf tunnel. Next one, saddle or base tunnels. Next one, slope tunnel. Next one, spiral tunnel. Next, classification of tunnel based on purpose. Conveyance tunnel. Next one, traffic tunnel. Based on material, hard rock, soft materials, water bearing soils. Next one is investigation of tunnel. First one, geological investigation related to bed of the surface, rock types, soil types, etc. Next one is morphology, petrology, stratigraphy. It is also studied in engineering geology subject in second year. Next, electrical resistivity method. In this electrical resistivity method, we got to study about position of weak zone. It means it like fault, fold, shear zone, etc. In this electrical resistivity method also studied in engineering geology 4th unit. This is the flow chart for investigation made at time of planning. First one, planning. Next one is water and land. In water, immersed tunnels and mined or pore tunnels are provided. In land, cut and cover tunnel and bore tunnels are provided. In mined or pore tunnel having 4 types: rock tunneling, soft ground tunneling, sem tunneling, difficult ground tunneling. Next one is this is the methods for drilling purpose. First one, rotary percussion and rotary percussion method for loose soil. Next, rotary drilling for rocky soil. Next, spacing 300 to 500 meter. It reduced 500 to 100 meter in geologically disturbed areas. Next one is lateral spacing 10 to 15 meter from ground level of tunnel. Next one is depth. These drilling methods are also studied in foundation engineering subject in this semester, 5th semester. Next one is setting out of tunnel. First, it have 4 stages. First one, setting out of tunnel on ground surface. Next, transfer of center line from surface to underground. Next one, underground setting out. Next one, underground leveling. In first step, transfer of center line from the surface to the underground. In underground shaft, interval of 500 meter along transverse line. In rectangular horizontal frame set at proposed location along AB. Next one, shape of tunnel having many shape. DR segmental roof section. It is suitable for subway or navigation channels. Next one, circular section. It have it withstand heavy internal external radial pressures. So the circular sections are provided mainly in sewers and water carrying purposes only. Then rectangular section. In rectangular section is suitable for hard rock and adapted for pedestrian traffic, costly and difficult to construct. Then X-shaped section. X-shaped section is carrying sewage only. Then horseshoe section. It is semicircular roof with arched slide and curved inward. Best shape for traffic purposes. Most suitable for soft rock and carrying water or sewage. Most widely used for highway and railway tunnels. Next one is size of the tunnel. In size of the tunnel, it is determined from utility aspect. First one, road tunnels, number of traffic lines, and gauge and number of traffic tracks, etc. Next one, tunneling method. It having 5 method. First one, cut and cover method. Next one, shield and driven method is shield and driven method is applicable only circular circular shape of tunnels only. And then for rectangular tunnels, 3 methods are used: cut and cover method, shield driven method, immersed tube method. Next one, the horseshoe shaped tunnels. By using drill and blast method, sequential excavations are used. Then oval shaped tunnels are under by drill and blast method, then sequence excavation method. Next one, this picture shows the tunnels parts. This is semicircular roof tower. This is the tunneling techniques. First one, cut and cover methods. First, these are the steps in cut and cover method. For first step, supporting beams are provided. Then excavated the excess materials. Then to fit the concrete slabs. This is the tunnel shield method. This picture shows the tunnel boring machine. In recent time, the tunnel boring machine is used for excavating the tunnels. In tunnel boring machine having many parts. First one, cutter head. Next one, bolt drilling machine, gripper, crane, control gapping, automatic shot creating machine, conveyor belt, etc. Other consideration: production of structural elements, fire reduction, fire protection, fire hydrants, etc. Then communication system, traffic control, tunnel drainage system, emergency egress, electrical and emergency response plan. Finally, tunnel portals, it should satisfy environmental and air quality. Tunnel should be hazard free. So today I shared some topics. I shared some points from the tunnel alignment and setting out. Next class, in next class we will discuss about some various topics from advanced surveying third year for third year civil engineering student. Thank you.